This is Professor N. Venkatachalapathi, Institute of Aeronautical Engineering. I would like to discuss about manufacturing process for mechanical engineering course in the second year, second semester. So, I'm going to discuss about forging process. So, in this manufacturing process, we have discussed earlier mainly casting process and the secondary process, which is welding process, and third important unit where we have to discuss is metal forming process. In that one of the important process is forging process. Okay, so now let us see how we can able to define the term forging, what are the types of forging process, and how we can able to discuss the different type of applications and limitations and advantages of the forging process. Look at in this forging process, we can clearly see that it can be defined as it is the process of heating the metals above its recrystallization temperature. You can call it as a hot forging process. But this forging can be defined as it is the process of mechanical working of metals. Mechanical working of metals. So that means the desired shape. So for example, in the right side, three-dimensional view. So you can see this is a forging process. Forging process. There will be a high tonnage press. In between, there will be workpiece kept, and we can apply the open die. Open die, that a lot of pressure is applied to that compression force in this presses, and so that the required shape or desired shape is obtained with the application of compressive force. So for example, whatever, if you take a pen also, if you apply some force, this circle will become some elliptical shape. Some change shape can be transferred with the application of the pressure. And also what we are supposed to do in this desired shape, which is obtained with the application of a compressive force by using presses. Okay, and one more thing, in a hot forging process, what is meant by a hot forging process? As you know that hot forging, which is comes under the hot working process. So the term hot forging can be defined as where the metals can be heated above its recrystallization temperature. So here another important term, this is what called recrystallization. We have studied in detail about recrystallization. Once again, the term recrystallization can be defined as it is the transformation of old nuclei into a new nuclei. This is what some small old nuclei will be growing, will be expanded, and it will be divided into some small thing, and which will be elongated, yes or no, and so that it can be transferred the shape. So this is what transformation of old nuclei into a new nuclei. That process we can call it as a recrystallization. The temperature at which recrystallization takes place we can call the recrystalline temperature. But whereas hot working means, the term hot working can be defined as the heating the metal above its recrystallization temperature. But whereas hot forging, in the hot working process, one of the most hot rolling is there, hot forging is there, hot extrusion is there. In that, let us discuss about the what is hot forging process. Okay, in the hot forging process also similar to hot working process, where here the metals can be heated above its recrystallization temperature. Okay, then it is compressed and squeezed into required shape and size. Whatever the required shape and size can be obtained by applying hammers, either it may be sledge hammers or pressing tools and some of the compressive machines, etc. Depending upon the size, we can able to apply how much pressure is required to change the transformation of the process. Okay, so this is what about the forging process. You can see the right side the workshop, how they are changing the shape with a large shaped workpiece, and by applying the tonnage will be, it is more than 10,000 20,000 tons for capacity of this pressing machine. And whenever you can able to transfer that workpiece in between, then you can apply pressure. This more than 1,000 and 2,000 tons of capacity can be applied pressure, so that that circle will be changed into a some elliptical will become rectangle, like that. Lot of blows can be applied. This is what you can say, the compressed and squeezed to the required shape by using hammer or press tool. So this is what we can, where the heat can be above 1400 degrees centigrade is a red hotted in condition, so that we should take some precautionary steps to do the exercise in effectively. So a lot of experienced laborers or workers are required to change the even small shape and small form of the workpiece. Okay, I hope this is what about the forging process. Now let us see in the classification. While discussing the classification of forging process, there are only the two type of forging. One is open die forging, second one is closed die forging. So in this figure you can clearly understand that this is a open die forging, open die forging process. Okay, so look at in this open die forging, the first, this is called die, we can call it as die. This is also die. So bottom die, top die, this is the workpiece. This is the workpiece, and it is original shape, how it can transform into a rectangular and square, again rectangle, square. This is what. So here inside they can enter into a circular rod, it will transfer into a square rod by applying the lot of blows and pressures, or repeated blows can be applied manually using the pressures. Okay, and let us see the open die forging. In this process, the forging is done in a heated work. So whenever the workpiece can be heated in a red hotted condition to achieve the required melting temperature, and by which the placing on a flat surface, this is what die, okay, known as a flat surface of anvil, through hammering the metal piece. You can apply the lot of blows, applying the pressure with the help of the sledgehammer, and different type of power presses also can be used to change the shape. Okay, so whenever the hammering is another important technique, where you can able to change the shape by repeated blows. So here the term blow is very important. If you apply one blow, that you can see, if you apply one blow, this circle will become some changes in shape. So that is what you can see the how. Okay, again when you wanted to change, this will become again different shape. Okay, this will reduce the size. So like that, whatever the changes of the shapes by applying the all the pressures also. And one important thing is, in this open die forging, they clearly explain that can increase the mechanical properties in this forging process whenever the workpiece is there, by applying the pressure, because it is a hot working process. Heated raw material can be taken into the consideration by applying the repeated force and pressures, so that inside the granules and all things will be eliminated, and finally we can able to achieve the required shape and size. So whenever by this process, obviously you can increase the mechanical properties such as tensile strength and flexural strength and compressive strength. All these mechanical properties also can be improved. And here, why it is called open die forging? So clearly understand by seeing the three-dimensional figure, the two dies are open to the nature, open to the atmosphere. So that we can keep the workpiece, and by fixing the two jars, and we can apply in this die automatically whether the shape either flat or circular or elliptical, and any shape also of the die, the same shape can be obtained in this case. And obviously for heavy forging weight up to 25,000 kg are produced. So obviously 25,000 kg of the weight can be produced in this heavy forging machines and all. Okay, so this is what about the open die forging. But wherever in this open die forging, the accuracy, dimensional accuracy cannot be obtained. Why? Because by applying the force or pressure through the hammers, exactly at the correct place we can't apply. Sometimes it may be vary. If you apply one pressure, one time may occur, next time it may change the position, so that some unevenness also can be occur. So that's what exact dimensional accuracy cannot be maintained in the open die. But where in the case of closed die forging, you can obtain the closed dimensional accuracy. So this is what about the open die forging process. Clearly says the definition of open die forging. In this process, the forging is done in a heated work at the proper temperature by placing on the flat surface of anvil and through hammering at the metal piece. This is what, if you take anything by apply pressure, automatically changes the shape by application of the pressure. And hammering, obviously it can be done by the repeated blows. If one blow apply, so for example, if you see, there will be a circular rod, there will be a circular rod is there. In this rod, when you apply this thing, how it will become? It will be transformed into some rectangle. Again, it will transform into some circle, and again it transform into rectangle. So like this, the original shape to the, it will reduces the shape, either cylinder or rectangular or prism. This can be reduced the shape and size by repeated blows when you apply manually, or sometimes semi-automatically or fully automatically also can be done. So this is what about the open die forging process. Next, coming to this type of process, you can see it is a very simple process and flexible. So this process, you can see, a man can doing open die forging, they can heat at the raw material and kept, and another person, another worker is applying the pressure with the help of the hammers. Okay, so that is why it is a very simple process, and it is a flexible, whatever where you can apply and where what type of shape can able to obtain, that can be easily done. And it is also very useful for producing simple shapes. So for example, especially simple shapes like U bolts, chisels, S type, okay, and L shape, these are all simple shapes also can be easily done by open die forging process. And others also, some rectangular shapes and circular shapes and some hexagonal shapes. So for example, you can see hexagon is like this, 6 faces, okay, either this or this type. So already have studied this in the projection of solids. Okay, the hexagonal plate, and when you wanted to change the cylinder of this thing, or obviously there will be a, and you can apply this, and this is a cylinder shape. Okay, so like that you can able to obtain a hexagonal prism, and how you can able to reduce the shape and size of the given workpiece. And coming to this hand forging process, you can see this is also called smith forging or hand forging process. In all the villages, they will follow this simple process, smith forging. So there will be a workman or foreman, and they can heat at the raw material into heat by applying the blows in the pressure can be obtained. And once you have achieved the temperature red heated in uh, color, immediately you can take into the workpieces and apply the pressure with immediate effect. If you change the time, if you use a lot of time to apply the pressure, this will cool and solidify, so that once it has been cooled and solidified, it cannot be done the original shape. So that is why immediately after heating the required temperature, immediately you can apply the blows with the help of the hammers to achieve the required shape and size. And another thing is, one side of the former is held on the parts to be forged, while other side is struck with the sledge by helper. This is what one side you can keep it, and other side is you have to apply the pressure with the hammer, sledge hammer, and there will be one or two persons is required. One worker or some helper should be there so that you can keep in the workplace, because it is a radioactive condition. During the temperature also can't handle the workpieces also. Okay, you can keep it, and by applying repeated blows with the help of the sledgehammer, the required shape and size can be obtained in this forging process. And let us see another important type of forging process is a drop forging. So in general, the main purpose of this drop forging is while manufacturing of crankshaft, connecting rods, camshafts, and spanners, cranks, gear blocks, levers, railroads, and also can be made with this draw forging process. The best example for draw forging also spanners, wrench, adjustable wrench, and crankshafts. So these and all are the best suitable applications, and this can be made with the this draw forging process. Just simply I can able to remove that friction rollers and brake shoe. Suddenly you can apply in that above the ram, so that what are the shape of the die, either low and upper die is there. If it is a flat shape means the flat form will be applied. If it is a semicircular shape can be applied. If it is circular means two semicircle. So you have to apply one half and other half also. You can able to obtain this type of application. So that is why in a drop forging process can be defined as it is the process of shaping the metal and increasing its strength. That is what mechanical properties, strength, hardness, impact, compressive, whatever the strength can be improved, we can supposedly use for forging process. And here, simple the principle involved in this forging process, general forging process is there will be an upper die is forced again at the heated workpiece position on a stationary lower die. So here there will be one lower die is there, lower die and upper die. So in between you can keep the workpiece, and there will be two dies can maintain by applying pressure above the ram. Obviously that is what by keeping a lot of rollers and friction shoes and all can be applied, so that the required shape and size can be obtained. And the best example for this drop forging is the wrenches, adjustable wrenches, spanners, and some connecting rods, gates, levers, and crankshafts, railroads, and pedal blocks and gear blocks. These type of applications are widely used in the drop forging process. Okay, I hope all the students can understand clearly about the forging process. Now let us see in this what you call press forging. The only difference between this drop forging and press forging is in the press forging you can use this some machines, pressing machines like some machines or hydraulic presses or mechanical presses. Mechanical means there is a crank lever type of presses. So there will be rack and pinion gear attachment. By applying the pressure, it can be expand at a certain type and shape, so that the whatever the shape can be obtained effectively. Okay. This is what about the basic principle in press forging. Press forging process can be major purpose of this similar to drop forging. Only thing is here we can use the single continuous slow squeeze action. So because instead of series applying of the impact to low pressures, but it may travel slowly. It will ram can be travel and continuous action of the hydraulic process. Okay, so the deformation penetrates deeper, so that entire volume of the workpiece can simultaneously and uniformly undergoes in a plastic deformation. Okay, So in a plastic deformation, obviously, in the case of draft forging, the energy is only transmitted into the surface layers of the work part. Okay, and this is what about the draft forging press forging. So where the draft forging is only connecting rod, etc., can be used in this. Press forging, only pressing machines, either different capacities of pressing, either 1 ton, 2 ton, 100 ton, 1000 ton, depending upon the workpiece size and shape, how much pressure is required. Such type of presses only are selected in this forging process. Okay, so this is what about the press forging. So almost all similar to the draw forging, but in the similar draw forging, when use the single continuous slow squeezing, but where in the case of this thing, multiple means it will deformation penetrates in deeper way, so that the entire volume of the workpiece simultaneously and uniformly undergoes in a plastic deformation. Whenever it can be heated simultaneously, giving cool time, immediately it will be cool. It will be cool and it will be cannot come back. So that is why it is a hot forging process. Okay, and where in the case of draw forging, the energy is only transmitted into the surface layers of the workpiece, surface layers of the work part. Now another important type of forging process we can call it as a upset forging. So this is what another interesting classification is upset forging. So upsetting is nothing but the basic deformation process. Upsetting in the sense it is a basic deformation process which can be varied in many types or many ways. Okay, that is what upsetting is, the basic deformation process which can be varied in the many ways. And the second thing, upsetting of the metals is a deformation process in which billet is compressed between the two dies in a press or hammer. This is what about upsetting of the metals. And in this operation, you can reduce the heat. You can reduce the height of the part while increasing the diameter. So whenever you can reduce the height, means obviously a diameter can be increases. Okay, so this is what about the upset forging. Now another important type of forging is roll forging. So roll forging also can call it as a forge forging. So in general, the roll forging can also be defined as hot forge rolling. So in this hot forge for rolling, what happened? So this process for simultaneously reducing the cross-sectional area and changing the shape, beaten bars and billets. These are the good applications related to the roll forging. So the applications are obviously the heated bars, billet and plates. By the passing through between the two drives or two driven rolls that rotate in opposite direction. One is, you can see in the clearly understand by showing the figure. So in this figure you can observe. So there will be workpiece will be entered through that roller. Yes or no? And this roll forging also can be defined as where it is a process simultaneously reducing the cross section area. Okay, we can able to use simultaneously by reduce the cross section area. But one more thing is the directions and have one or more matching impression in each roll. So in this diagram, you clearly understand the what is the roll, what is the die, and how we can able to project this roll forging process in the industrial application. So another important thing is upsetting process. So this is the one interesting process. Upsetting process means, you can see from the left side diagram. So first portion is heated uniformly its length. Second is heated and middle way. So third is end heated and only one and only. Okay, so and third but not least, two hands are heated. So whenever the two hands are heated, obviously the required shape can be obtained in this evening itself. Okay, so here the dice, which is also called the tools, press tools, typically used to widen the diameter. The diameter to increase the thickness. Whenever if you say, so this is the component, by applying the pressure repeatedly, what will happen? It change the dimension. So there is no other alternative. We can change the dimensions. Accordingly, you can able to apply some precautions for the offsetting process. The main purpose of offsetting is only if you identify all type of materials and shape, this can be done effectively. And dice, which is also called the tools, we will speak, and these are can be used effectively where the increased thickness. Okay, and one more thing is, tools are arguably the most important stage of the offset forging, as they provided shape to the forged them. So this is what important. And the last point in the this offsetting process, due to level of accuracy and intricacy required, they are produced by highly skilled tool maker. So here one interesting thing, the highly skilled, so their expertise in automation and semi-automation, how to write the programming, even though the from seeing the diagram can easily understand how do you project it. That is what about the this tools you can add it. And due to the level of accuracy and intricacy, so due to level of accuracy and intricacy required, they are produced by highly skilled tool maker. That is what I have been explaining. Highly skilled tool makers, and often the used state of the art and expensive industry. State of the art and expensive industry. This is what another interesting. Okay, and expensive industry also can be widely used in this setting process. Okay, next point. So this is drawing out. Another important point is drawing out. So let us see in this figure about the most basic process of the forging is drawing out. Drawing out, since there will be one rectangular rod is there. So this can be applied like this slow. Okay. So drawing out, the main purpose is, it is a transformation of diameter can be reduced, length can be increased. Diameter is reduced, length can be increased. So in this drawing out process, you can clearly understand that there will be anvil, and above the anvil you can keep the bottom fuller. This is a bottom fuller and top fuller. This is called workpiece. Okay. So this is called workpiece, and there will be two fullers will be there. One is bottom fuller, second one is that top fuller, and the stack can be between in between the two fullers, so that the required shape of the die can be obtained effectively. So this is what about the some techniques involved in the drawing out. And here one thing I wanted to add here, I wanted to add it, so that this length can be increased, diameter can be reduced. Length can be increased, the diameter can be reduced. Okay, so this is what about the drawing out. Let us see. The first and foremost thing is, this is what this figure also, three-dimensional figure, where you can perform the changing of the shape of the workpiece. Either it may be the anvil or bottom fuller or top fuller, handle with a hammer, and finally shock. We should be able to attract the shock absorptions in this method also. And it is important to remember that hot iron moves in the same way that stiff clay moves. So this is what about the drawing out. Now let us see the how we will explain in the punching process. So whereas punched out is called the blank, and piercing, making the hole is called the piercing process. Okay. Now look at the types of forming process. Some important thing I would like to share. What is meant by punching or piercing? Both the terminology are same, but depending upon the usage and percentage only, you can able to understand the punching process. Okay. So punching mainly workpiece create what you call the shearing. So here there are three things should be understood in any mechanical working or model working process. In this first case, you can see the how you can able to explain this sheet metal or paper and vulcanized fiber, and there will be scrap slug also, where you can the whole is deposited into the die process. Okay, depending upon the material being punched, this slug may be recycled and reused or discarded. Okay, so this is what about the and punched out called the. So you can see the if you punch it and remove that thing, you will get. Okay, this is called punching or making the halos only. This will be applicable. And once again, I can read the definition of punching. Punching is a forming process that uses a punch to form a tool called punchu, and though the workpiece to create the hole via the shearing process. Okay, again, if you discuss with this shearing process, okay, it is not coming. And coming to this is scrap. What is by scrap? So scrap slug from the hole is deposited into the die in the process. Okay, and depending upon the material only, you can able to discuss. Okay, now look at another important thing is punching process. Okay, punching means punched out what we can call it as a blank and making the hollow portion in the punching process. And this is called bending process. So it is a very simple metal forming process or mechanical working process. Whenever you wanted to make a U shape, you want to shape V shape and L shape and S shape and channel shape, or all these type of shapes, simply you can use the process called bending. So bending process. Whenever you can able to apply this bending process, there is a straight rod and sheet can be put in the circular bar or horn, we can call it as a horn. Then you can apply pressure so that it may be tent, it can be inclined, it can be changed the shape in a L shape or channel shape or circular shape. This shape can be obtained. This is called the bending. In general, the bending generally where you can able to add some allowances, bend allowances also. Okay, so while discussing the bend allowance, generally you can able to calculate the allowances by using channel welding or wipe die or some different type of thing also can be used. Okay, this is what about the forging process. In the next session, I am going to discuss about the rolling process. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.